Hello, welcome to the dark side. So, we're going to start with chapter 1. Chapter 1 is about light decay and fall off. Here is my little scene. Alright? So, we're going to study light fall off, the built-in decay, intensity curves, color curves, decay region, and as a bonus, how to fix overburnt areas when you have decay, very classic problems, and what about if you need curves on point lights, because point lights don't have them per default. So that's going to be our chapter 1. So here is my little scene, alright? So let's see what I have there. So what I have is a very simple little scene with a series of a line, of objects put right after the other. What I have as well is let's render like that. You're going to see it. What I have is just I'm going to use simple light. What I have is a little bit of final gathering, to have something in the shade, not just being pitch black. That way we're going to see more better what we are doing, and that's it. So let's start. Let's delete my light and start in total darkness. Alright, so let's create a light. I'm going to start with, of course, a spotlight. Okay, a spotlight, something I don't know you guys, but what I really hate is having a light that looks very small. I'd like to see the direction. I'd like to see where my light is, not just a point in space. So, exception with IR lights, of course, it's a bad idea to scale light like that, to scale the transform node, because when you do that, you basically take the risk of changing a lot of your lighting parameters. So, a better option is to scale only the display of your light. So, how you can do that? That's kind of a Autodesk secret, I'm afraid. So, it says, well, you select your light, and you go in the shape light. On the shape light, you have object display here. And you see that? Locator scale. That is safe. This option only scale the display, not your light itself. So it's totally safe. Now, I have of course a lot better idea of what I'm doing. Alright? So here is my little scene. So you know that you can look through your camera, look through selector. Alright. So that way I can really place it. Something maybe sometimes you have a very small camera for your spotlight. I mean very small. Or here, even that I would prefer to have a bigger camera. What you can do safely is that as well. Is say you see spotlight, make sure you have shape on. What you can do is open that, and you see you have your light shape, of course, but you have as well a temporary camera that was created when you use a look for selected. This little camera, it's not related to your light. So what you can do is to, for example, increase the length 30. That way I can see a lot more what I'm doing. But I'm not changing my light focal, That's my light cone angle, I mean. So that's a good thing. Just a display. Now I see a lot more, what I'm doing. Yeah? So let's do an IPR of my camera. So, quality is not great, of course, but that's enough to show you what I want to show you. So let's study what's happening. So let's put my light relatively close, to my object, something like that. In that case, now we're going to see a nice fall off. All right. That's my light. So I'm going to put my, I have a model of a spotlight. So I'm going to put it for the moment out of the way. Right here. All right. That's my light. Okay, per default. So you know that, of course, in Maya, you don't have your light doesn't have a fall-off and even doesn't have shadows. So what we can do real quick, is to create some shadows. So I'm not going into the settings. The settings here. What I'm going to do is just to create some ray trace shadows real quick. Okay, that's basically about it. So let's do another IPR. Here it is. All right. So what I want to show you here, it's per default. Light don't have a fall-off. What's happening here, even if I increase my light intensity a little, at 2, the amount of light received by this object is the same for the fan here than for the soccer ball here. There is no fall-off with the intensity. If I temporarily remove my light shadows, you can tell that indeed that's really the same. That's the same thing. Right. So fall-off. The first way Maya we can use in Maya is what they call the decay rate. No decay per default. So there is 3 different built-in decays available. I'm going to start with quadratic. Quadratic is probably the one you're going to use. That's the one that supposedly mimic the best what's happening in our world in terms of decay. So let's use it. And when you do that, you see what's happening immediately. It's your light disappeared. Your light disappeared for a very simple reason. It's now the light intensity is decreasing according the distance, which is really cool. That's what you want. But because your intensity is only 2, what's happening? It's 2 at the origin of your light, and because of the distance, of course, what's happening? 2 become 1 and become 0, maybe somewhere here. So no light. So what you have to do is of course, to increase your intensity. And when I say increase, I say increase a lot. Like numbers that you usually wouldn't use, like, 200, wow, 400, and you see now I have indeed a nice fall-off. Let's put my shadows back. See, now I have a fall-off, but you see what's happening is, if I really want to have a lot of illumination here, I have to push these numbers a lot, like that, like 2000, you see, so like I would say, crazy number. Let's get even closer to this first guy, to the first spotlight. But something happened when you do that. It's that you get maybe a nice, very natural type of fall-off, but what you get as well is overburnt areas. That's a big problem there. There's 2 or 3 limitations here. First limitation, indeed, if your light is close to your object, well, you are asking for a real light. A real light is mean heat, and closer your object are from the origin of your light. 2000, indeed, now your object close to your light are overburnt. And second limitation, of course, you have no access to the distance for the fall-off. It is what it is. So that's 2 characteristics or limitations that might, from an artistic point of view, or technical as well, be a real problem for you guys. So let's see the other one. If you use linear means that the fall-off is a lot longer. Because it's a lot longer, you need indeed less intensity. But your problem is going to be the same. As you can tell, even if you like more the fall-off as a linear, you might still have burnt around. You see, you have the decrease along the distance is a lot longer. Reversely, if you use cubic is a lot shorter, which means that as intensity, I need a lot more. So let's maybe 20,000. So really numbers that usually you wouldn't even try. And you see the fall-off is a lot shorter. But same problem, overburnt areas. So let's go back to quadratic. Quadratic at maybe 3000. And you see 3000, that's your problem. Is maybe the fall-off is exactly what you want, but you have this big problem. So that's one of the bonus for this seminar, is how to fix the overburnt area when you have a decay on. Well, there is different ways of doing that. You could say, well, in that case, what I can do is maybe, per material, decide that you're going to decrease, indeed, the diffuse weight. But that is not a great idea, because you have to do that on a lot of maybe materials, and on top of it, you start to cheat with how your material looks like because of a lighting problem. You cheat with your shaders to overcome a lighting problem. Rarely a good idea. There's a better way. In mental ray, you have lenses. On lenses, you have the Mia exposure simple. This little node here can help you to fix that problem, because with the right settings, with little node, might be able to tone down your overburnt area and left intact your better shaded areas. So let's see how it works. It's a lens. So lens means, of course, that you have to put that on your camera. So in my case, I have a camera, what I call my render cam. It's a mental ray. This is a mental ray node. So in a camera shape, when you go down the list, you have indeed a mental ray tab. On the mental ray tab, you have a lens shader input. That's where this guide should go. So let's do that. Something happened immediately. Your image become overbright. It's overbright because per default, these settings are set a peculiar way. First thing you have to do is to put this setting back to a state where they won't change anything, which is pedestal 0, gain 1, ni 0, compression 0, gamma 1. In that case, I'm back to where I was starting from, which is exactly what I want. Now, it would be too long to really go into details there, but the two settings you need to change to really work on that area is the knee on the compression. Knee, you need a small number, something like 0.0, maybe 0.05, because you're going to work only on the really, really brightest area of your image. So maybe something like that. Nothing changed because the next guy, compression, has to be changed. And that's the fun start. If now I'm starting to move the compression, as you can tell, now I can tone down my very, very bright area. So let's do a before and after, 0, 1, 0, 0, 5, 1, 1. So let's keep this image for comparison. And now, let's move the compression at, for example, that's too much, but maybe, something like 2.8. And that's the difference. Before, this area is totally overburnt, and even if you have, 32 bits, there is maybe nothing you can do in comp to underexpose that. It's burnt. But with this little node added on your camera lens shader, with the knee at maybe 0.05, the compression maybe at 2.8 or a little bit less, you tone down your value and you're good to go. And as you can tell, only the brightest area is changed. Nothing changed, almost nothing changed there. So just with 1 second work. So I think that is very useful. All right, so next we're going to see the intensity curves, because your problem here is something overburnt area, even if you can fix it with a Mia exposure simple. But sometimes you want more control. Sometimes what you really want is having a light intensity maximum start, maybe here, and you want the light fall off happening maybe here. So something that is not, physically correct, but maybe something which is artistically correct, because it is what you need, and that's it. So how can we do that? If you keep working with the decay rate, nothing you can do. I mean, the decay rate is the decay rate. You can't touch on the close and far planes. It is what it is. So we're going to work with the next guy, the intensity curve. All right. So now let's see what other methods we have if we are not satisfied with the built-in decay. When we want really total control about the amount of intensity at the beginning and the amount of intensity at the end. All right. So I put my light back at what it was at the beginning. So no decay. So same amount of light near my light or far away. All right. So what you have now to play with is what they call intensity curve. So you need light effect intensity curve. When you do create, something like that might happen, something really funny, like kind of concentric areas of light. Well, don't freak out. If we reselect our light again, we're going to see that now intensity input is mapped with some values. So let's take a look here in the hypershade. Hypershade, that's what we have. We have our light, and we have, you see, what they call the intensity curve here. Intensity curve, it's nothing more than a graph. So F to see it, on an animation graph, very, very similar of what you create when you keyframe something. But here, because we are doing that, we have created that on a light, we are not talking about animation. We are talking about distances and about intensities. So what we have here is just 0 mean in that axis, 0 on Maya units. So basically mean that at 0, my light intensity is 1, decreasing, going back, decreasing, going back, decreasing, going back, and finally with this slope going to 0 at, as you can tell here, 90, probably, let's see, 100 Maya unit from the origin of my spotlight. That's where these concentric effects are coming from. So that is really not useful, really not. So the first thing you have to do is maybe to delete all that point and have a more decent spline, because that's really what you want. And now, what you have to do is to decide exactly where you want this fall-off to start in space, how many Maya units from the origin of your light, and how far the light is going to decrease. And because it's a spline, you can really design your spline, which is really the fun part. So really, painting with light. That's really what it is, painting with light. So how can you do that? What you can do, is maybe to look at your orthographic view, which one? Maybe in my case it's side. And what you can do is to use the measure tools, the distance tool, to have a better idea of what you're doing. Or maybe what you can do is say, well, put a starting point of your measure tools here and see, well, apparently, in my scene, 16, I guess, or maybe no, a little bit more, 17. So it's where my light is, where my object is. The closer object is from my light. All right. So that's the first one, and maybe go to the final guy. So let's put the display of the grid on, and the last guy is at something like 80, 82, 83. In my case, when I select my light again, I can tell that if I want, I can put the maximum intensity for my light as maybe at, at 1, of course, but maybe not at 0, so at the origin of my light, but maybe at 17. And what I can do is say, well, here, the end of my spline, 0, could be maybe at 80. In that case, I start to really shape my curve. And if I want an intensity at more than 1, of course, I can. So what you can do is maybe IPR is going to start to maybe say, whoa, that's too much for me. So don't trust IPR too much, generally speaking, or let's see what we got. Here we are. All right. So what you can do is say now, I want really my fall off maybe finishing here. So in that case, the end of my spline, instead of being at 80, which is somewhere here, maybe going here at maybe 40 or 50. So you see, you can't really trust IPR here. So render again. In that case, as you can tell now, my distance decrease. So I can really, that way, really shape what I'm doing. So for example, in 30 now, so by comparison, and you're going to see this area. So now, so intensity of 2, being 2 here, 2, probably here, and decreasing to 0 here. So that's how you can really shape your light decay if you are not satisfied with the built-in decay. All right? So that's how it works. So now, Maya offers as well the same thing for color curves, which means that you can as well change the color of your light according the distance. All right? So what I'm going to do is put that curve at 80. And let's take a look. So to lit more my object. Okay, here we are. Nice fall off. And I'm going to do something now with color curve. So create. When you do that, reselect my light. Now I have as well, see, an input connection in my color. When you look at your graph editor, indeed, now I have the same thing, that kind of very funky looking spline that you probably don't want that, you might want is something like that. And now, it's the same thing. You can, with your color, decide that your light is maybe white at 17, become red at 40, and decreasing over the distance to black to 0. So let's see if we can do that with IPR. Here we are. So let's put all these red, green, and blue curve at 17. 2 intensity, so white, more than white, of course. So as you can tell, IPR decided that it was too difficult, I guess. So let's see. Here we are. And now what you can do is decide that, well, in that case, maybe what I really want, is to decide that, well, this curve really, I want, for example, to place to change, for example, the curve. So see what we have, you see. So let's see what difference it makes. Does that make? Here we are. Now, because I'm decreasing the red over the distance a lot faster than the two other components, green and blue, my light is now changing its color according to the distance. So very nice artistic type of effect. So is it really useful? From time to time. I would say it's not very realistic because it's trying to, in a way, to simulate kind of an ambient area which is at a different color, so not exactly photoreal, but you can use that to really make your image look richer, like not just simply white to black, but maybe white to yellow to red to black, to have maybe something that looks a little bit more interesting, even if again it's not totally photoreal, like maybe something like, for example, say, well, something like that. And of course you can create more points to have some special effects. So let's see. Here we are. So just a tad of a difference. That's how to use the intensity curves and the color curves.